Hi, everyone. Welcome back to Dragonfly Engineering. So today we have a special guest. This is Gaurav with Niobia,
Hi everyone.
and he is working on a startup that uses AI for process development and process optimization in manufacturing. And April actually has interacted with their company and done some consulting with them. And they've come today to actually try out their AI product with using our injection molding machine, kind of a real world trial for how the AI system will optimize the process of injection molding plastic parts. So we said, great, we'd like to see how this works out. So would you
Perfect.
like to
Tell
fill
us
us in a
about
little
your
more?
company and tell us maybe what we should expect today.
Perfect. Yeah. Hi everyone. I am Gaurav from Niobia AI. We are building an AI process engineer that can help all manufacturing industries decrease their OPEX. We are trying to increase the capacity of any manufacturing plant by by shrinking the troubleshooting cycles of any manufacturing as much as we can. So today at Dragonfly, we are going to try Niobia AI on injection molding. This has
Right.
never been done before.
Never been done.
Yeah, and so we are going to be the first ones to try and see if AI can understand injection molding and actually help out somebody who has never done injection molding learn it much faster and actually troubleshoot issues on the manufacturing line in injection molding. Let's get started.
Yeah, should be fun. And as you can see, we've been growing. This is one of our latest acquisitions, a 530-ton clamping force molding machine that we got about 3 months ago.
Yep.
And yeah, so we support people with injection molding their products, either instruments or a lot of consumables that run on people's instruments. So some of the basics of injection molding we can go through with looking at this machine. The machines vary from just very small, almost benchtop molding machines, which are like 20 tons of clamping force, all the way up to this 500-ton clamping force machine. But the procedure for injection molding is basically we start with plastic pellets, little tiny pellets like this, and we load the pellets into a hopper. Sometimes you have to dry the plastic pellets before you load them into the hopper of your molding machine. And the process is that the plastic drops through the hopper into a screw auger, which melts the plastic pellets into a liquid. And then there's a screw auger that actually moves the plastic towards the nozzle of the molding machine. And that's mixing the plastic as well as continuing to melt it. In fact, we have a screw auger on the floor here.
Yeah. Maybe
So this-
one point about this nozzle is that whenever you're actually running product, the nozzle would be butted up against the mold so that the plastic will go into the mold while it's clamped.
Yes. So this is a spare auger that is in that injection unit that we were just looking at, and the plastic pellets ride in these this auger like framework, and they are pushed forward to the actual injection nozzle. This nozzle will advance to the mold through the platen, and there's a tiny little hole that the nozzle aligns with, and then this injection unit will push all of that hot plastic into the mold of the molding machine itself, or that's loaded in the molding machine. Of course, before you inject the plastic into the mold has to close. So back here is what's called a toggle clamp, and in the beginning of a molding cycle, this toggle clamp is open, so the last part that was molded falls out from ejecting, and this hydraulic cylinder pushes pins in the back of the mold to knock out the finished molded part. But obviously the mold has to be open for you to eject the part out. Well, the next step then is that the mold closes, and this toggle clamp creates the 500 tons of closing force, and then the nozzle will inject plastic. So the molding machine clamp will then close after the last part is ejected, and then the nozzle will advance to the opening in the front of the mold, and then at which point, when the toggle clamp locks up, which is kind of like a vice grip, the clamp is holding the mold shut with 500 tons of force, and then the injection unit will advance forward, inject plastic into the mold cavity at very high pressure. It can be up to 10,000 pounds per square inch, and that is where you have to balance the force of the plastic trying to push the mold open from just the hydraulic force of filling out your mold cavity. That amount of force created by the injected plastic needs to be less than the holding force of your clamp. So you size your molding machine to the size of the part that you're going to mold. Bigger parts need a bigger force to keep the mold shut while you're injecting plastic into your mold. And you do need to inject with high pressure so that you can fill out the mold and pick up all the details of your molded part itself. And then at which point there's a period of time where the plastic has to cool in the mold. And sometimes you actually cool down the mold with cooling lines like this to help pull the heat out. And then after a period of time, which is one of the adjustments or the process parameters that AI could assist with, you then open the mold when the part is strong enough to be ejected out. And then this ejector system with this hydraulic cylinder will push pins through the mold after the mold half is opened and eject your part out. And then you inspect your part to see what defects you have in it. And then you have to make adjustments to your process parameters with either temperature or of the plastic, temperature of the mold, the time it takes to inject the plastic in, the amount of pressure that you're pushing the plastic in, and on and on. And then we'll discuss all these parameters that are interplayed to get a good molded part in your injection molding machine.
I think it's probably worth noting that there's different styles of molds that can be made.
Mm-hmm.
Pull pole or spring style. And then also too, some of the art of mold making is where to position the pins. The pins help the part eject, but how to position them, different sizes, making sure that they don't get stuck.
Yeah.
That's actually, some of the rubber meets the road mold making
yeah, usually
items.
You want to have more ejector pins than less, because the more pins you have, the less probability that you're going to have damage from your pins pushing the part out of the mold.
Right.
So other things to consider with the mold design would be the venting, because when a mold closes, it's full of atmospheric gas. But when you shoot the plastic in, and usually that takes about 1 second of time, all of that gas or air that's in the mold has to get out of the mold so the plastic will take its place. So there's also gas vents and things like that to consider in a mold design, which also play into the process parameters. If you have a mold that has trouble getting all of the gas purged out when the plastic is squirting in, then you need to slow down how fast your plastic is pushed into the mold. So again, mold design affects process parameters and quality of part and cycle time, which is also a key factor in production.
Now we are going to do some injection molding. This is again my first time doing injection molding ever. Dave, why don't you tell me what this tool is? It's a much smaller version of the tool we saw on the outside, so perfect for learning.
Yeah.
But yeah, why don't you tell me how to set the recipes in this tool, and then maybe I'll give it a shot of molding something myself.
Oh, okay. Yeah, so this is obviously a smaller molding machine. This one's newer than the larger one out in the back. So it has a electric hydraulic system as opposed to just the kind of the old style, more of a farm tractor hydraulic system on that large molding machine. Mm-hmm. And so this one's more precise, and it's also a much smaller clamp force. So this is only 25 tons of clamping force to hold the mold together. So it's like 20 times smaller than the last one that we looked at. It has a more advanced interface and a lot more precision. This one I actually log data on the profiles of the injection of the plastic part. It'll do SPC processing of the quality of the shots over time throughout the whole day, and it can actually respond to if your process window moves out of your tolerance range that you want. It can tell you, hey, something's not right, or it can shut off and tell you something's not right.
That's exactly the data the AI tools can use to give us some more intelligence on these operating these tools.
Yes, exactly. So there's a little smarter machine here. Okay, so for this molding machine's operation, it provides this little track of major steps in injection molding on the screen, and as it's running through a part, it'll highlight each one of these, and it does this kind of continual circular, fully automatic molding operation. That's where you can just walk away, and it just goes through these steps until you reach the part count that you request, which in this case is 8,000 parts.
Wow.
And 21 seconds, or 21.27 seconds was the last cycle time for this particular part.
So it can produce a part in 21.2 seconds. It can produce one part.
Yes.
That's amazing.
A full cycle.
Wow.
So the main cycles for all injection molding are depicted with these icons that light up. The first icon would be the mold close operation. And that is the beginning of a molding cycle where the hydraulic clamp will close the mold with up to 25 tons for this molding machine. The next step is depicted by this icon, which is carriage forward. And the carriage is the part of the molding machine that has the injection unit, which is the hot nozzle with the auger inside, and the plastic hopper and the nozzle itself. And this carriage moves forward until the nozzle makes contact with the input screw of the mold. Now there's a hole between the platen and the mold area, and that makes a plastic seal.
That's where the flowing plastic goes into the mold?
Yeah,
Okay.
that creates the path for the plastic to flow into the cavity of the mold.
I see.
The next step is the actual injection of the plastic. And there's two steps to the plastic injection. One is the high velocity, it's called the fill, which is a lower pressure, higher velocity filling of the hot plastic into the mold. And the idea of that is to just get 95% of the plastic into the mold itself and roughly form the part. The next step after that is the molding machine will switch to a packing phase at a prescribed distance of the amount of plastic or the shot size that's entered into the mold. And in the packing phase, the machine switches to a high pressure and a low velocity or a low flow, because it's just filling out the last 5% of your part and pressing against the mold cavity walls to pick up all the detail of the mold itself onto your plastic part. And that happens for a few seconds. And then after that step, the molding machine is thinking towards the next part that it's going to mold. So while the nozzle is pushed up against a filled and packed mold, it acts like a cork, and that's a good opportunity for the molding machine to fill the injection unit with the next shot of hot plastic. So the auger spins, it draws plastic from the hopper into the injection unit, melts it, mixes it, gets it ready for the next shot, while it's still pushed up against the filled mold. The next step after that is the screw auger in the injection unit, if you choose to, will suck back a little bit, and that will pull some of that hot plastic away from the nozzle orifice. And that will help prevent that hot plastic from drooling out while the mold opens and you're ejecting your part.
So hot plastic drooling out is like sometimes you see on a plastic there's a bump or there's like a streak there. That is the hot plastic drooling out?
It can be if you don't suck back and some of the leading edge plastic starts to oxidize and get discolored or start to solidify. And then you push that into your next part, then you've got that leading edge plastic defect
Wow.
in your part. So you may actually see a little disc of plastic
Yeah.
stuck
Yeah,
in
yeah.
your part. Or if it's a really sensitive plastic to oxygen,
Yeah.
then you may see a brown streak because it's already starting to burn because it's exposed to atmosphere.
Okay.
Like nylon is an example of very sensitive to discoloration from. So if you suck that plastic back into your injection unit in a safe space,
Yeah.
then it's better. You also don't get as much mess in the front end of your molding machine because that plastic's drilling out, and then you just get
Creating a
a
mess.
puddle
Yeah,
of
yeah,
it,
yeah.
and it's a mess. The next step after the suck back is the machine will let the plastic in the mold
Okay.
solidify and cool down. So that's this icon that shows the little snowflake and a timer. And that can be a few seconds to sometimes a few minutes. And that's mostly a function of how thick your part is. Like if you injection mold a solid plastic ball,
Yeah.
the molding machine may have to sit there for like 2 or 3 minutes,
Okay.
waiting for the heat in the middle of that ball to get out to actually become a solid plastic ball, not a ball of molten plastic. But a very thin-walled plastic part, it loses its heat a lot faster. So in that case, it would only be maybe 5 seconds.
Does it
What-
also, sorry, does it also depend on the type of plastic you are using?
Yeah, the heat capacity of various plastics is different. Some plastics hold a lot of heat to get melted. Other plastics melt very readily, which means that they also cool off and solidify very readily. So I think it's specific heat or heat capacity of the plastic.
Okay.
So wall thickness, that's a lot of times you see a lot of plastic parts are just a shell because you don't want to waste cycle time waiting for a big blob of plastic to cool off. There's other things like shrinking that we're going to get into later
Okay.
as far as molding defects, but
Yeah.
anyway. So after the mold has gone through the wait cycle, it then pulls the carriage back if you want it to. Sometimes you don't want it to. And then the next icon is to open the mold. So the molding machine will open the mold, and if you design your mold correctly,
Yeah.
your part is going to be stuck on the moving side
Backside, okay.
that has ejector pins.
Okay.
If you design your mold incorrectly,
Yeah.
then your part is stuck on what's called the A side,
Okay.
and your ejector pins are just going to push air because your part is on the wrong side of the mold. So the art of mold making is that when the mold opens,
Yeah.
your part needs to be on the side that has the things that's going to get it out of the mold, which is the ejector pins.
That makes sense.
So there's a lot of art in like figuring out which side of the mold is going to be more grabby for your part, and you want that to be on the eject side. So
Mold design is like definitely a big part of
oh
injection
yes,
molding.
definitely, yeah. But the worst sinking feeling that you get
Yeah.
is when you load your mold the first time,
Yeah.
and the molding machine opens it up, and your part is stuck on the side that doesn't have ejector pins.
And that wastes like a month of your work of
It
creating a
can.
mold.
There's
Oh,
ways
wow.
to fix it, but if it's really stuck on the A side, then
Yeah.
you pull the mold and you go back to the drawing board, as they say.
Okay. Okay.
Okay, so assuming mold open happened and your part's on the right side,
Okay.
then the next icon is the eject icon. So the ejector pins will push through the side of the mold,
Yeah.
or through the back of the mold, and actually knock your part out of the cavity of the mold.
Okay.
Followed by, if you want, there's an additional wait time. And then the cycle repeats, where now the mold closes and you run this track again. And you just do that continually for however long it takes to make 8,000 parts.
Okay.
At 21 seconds. And actually, this machine will calculate your full cycle time. It'll tell you, oh, this will be 24 hours,
And then
to
you
make
just,
your
just go
8,000.
away and then come back to
Yes.
all of your production done.
Yes, if all your parameters are set and your mold is good, then you just turn the lights off and you go home.
Okay, so what I learned is like the important parts of this process, I think, is the temperature of the auger that
Mhm.
actually sets the liquid cooling, the
Yes.
cooling of the plastic, right?
Correct.
The
yeah.
time taken is
Which are these settings here?
yeah, those are the time taken is also a very important setting, and the
Mhm.
mold design. I think we can't stress it enough. Mold design is like the most important parameter.
Yes.
And also, I think the
Well,
pressure.
and by extension, your part design.
Part design, yes. And the pressure is also a very important part of when the auger is pushing the liquid into the mold. The pressure of that, the force of the pressure of pushing the liquid into the mold. That's also an important parameter we have to optimize there.
Correct. And that has a profile that you can prescribe
Okay.
with multiple settings. And if your pressure and or velocity is too slow or too small,
Yeah.
then you get what's called a short shot,
Okay.
which that means that you didn't get enough plastic into your cavity.
Hopefully you won't.
Yeah, and what can happen is if you're too slow, the plastic may half fill your cavity, but then it says, "Oh, I'm cooling off," so it'll actually cool off in your sprue,
Okay.
and it's called a freeze off. And then you can push as hard as you want,
Yeah.
but you've got a blockage now because that plastic cooled off. So
Okay.
you gotta push it in fast
Okay.
with the correct amount of pressure. But if you push in too hard and too fast,
Yeah.
you'll actually push your mold apart, and then you'll get flash.
Oh.
So you'll get a short shot if you're too slow and not enough force, or you'll get a flash if you're too hard and too fast.
Okay. Okay. Well,
And you can,
hopefully we don't get any short shots today.
Well, I'm sure we will. We can get both. Just jack up the pressure, and we'll get flash or a short shot.
Okay. Why don't you go ahead and start a run so to show me how to do it, and then I will try to injection mold something on my own.
Okay, so right now we're in setup mode.
Okay.
That's this caution thing.
Mm-hmm.
And if there's a fault or some problem, then the machine will switch from any other mode back to setup mode.
Okay. Okay.
So manual mode is where you can actually manually do the operations that we described here. So these buttons kind of do the same thing as the injection over here.
Okay.
So I'll hit with the carriage back, I can hit this eject button,
Yeah.
and you can see the depiction of the auger down here.
Yeah.
Squirted plastic
Squirted in, yes.
until there was zero plastic left,
Okay.
or minus 0.2. And now if we wanted to fill the injection unit again, then we can hit this auger button,
Yeah.
and with this one you hold it down, and you can see how the
It just
screw
moved
auger
back, yeah.
moved back because it was sucking in more plastic
Yeah.
and melting it at the same time.
Mm-hmm.
And if we wanted to suck back,
Yeah.
we hit this button, and you'll see how it went back a little further.
Yeah.
That
Yeah.
way we're not drooling the plastic.
Exactly. Are you going to refill? Are you going to take all the plastic that's in the hopper out first, or?
No, we'll just, eventually when we want to add color,
Yeah.
then we can pull this out and add some color.
Okay.
But just for initial shot,
Yeah.
sometimes it's better to just see the virgin plastic.
Yeah. Let's do it.
Okay, so the next mode of operation outside of manual is the semi-automatic mode.
Mm-hmm.
You can see these arrows going in a circle,
Yeah.
but then they stop at that little line, that
Yeah.
blockage line.
Yeah.
That
It's not
means,
connecting all the way.
yeah, so that means this machine will do this
Okay.
sequence of events once and then stop
Ah.
until you do it again.
It's an open loop. It's not a closed loop.
Correct, yeah.
Perfect. Okay.
And that's usually used for startup. You know, you want to, if you see a problem, you don't want it to just keep going. You
Yes.
know, so you want it to do one cycle,
Okay.
stop, semi-automatic mode.
Makes sense.
And then this is fully automatic mode, where
Yeah.
the semi-automatic mode has worked perfectly for a few times,
Okay.
and you're comfortable. Then you can just hit fully automatic, and then the machine will just keep
Go on.
going,
Yeah, yeah.
like a sewing machine or something. That's probably not the best. But anyway. All right, so we're going to go to semi-automatic mode,
Yeah.
and normally this would highlight green.
Mm-hmm.
So the machine is saying there's something that needs to happen that isn't ready yet, and it could be that suckback is not there. Maybe the suckback wasn't enough. Oh, okay. So now the green light is flashing.
Okay.
That means that the machine checked everything,
Mm-hmm.
and it's happy with all of the initial conditions to mold apart.
Okay.
So I was manually getting things set up, and I didn't suck back enough.
Okay. Makes
So,
sense. Yeah.
and then if I would dig around, I would find that
Yeah.
under, let's see, the suck back. Oh yeah. So suck back should be 4 millimeters,
Okay.
and we weren't at 4 millimeters yet. So, okay.
Yeah.
So now we go back to the main page,
Yeah.
and we can hit the green. Or do you want to hit the green button?
Sure.
And then the machine will mold its first part. You can see its progress in this little track here.
Okay. Yeah, that's pretty fast.
Yeah. That was good. And there's our
Notice
first part.
something. Can I take it out?
Yeah.
Wow. Okay. I definitely see some streaks here, but yeah. Okay. This is our part. This is the two squares, which has different thickness. And is this the part that needs to be torn off? This top thing?
Yeah, so this is the sprue.
This is the sprue.
This is a runner, even though it's very short.
Yeah.
And then this is the gate, which
Okay.
is the actual opening into the mold cavity.
Do you just twist it and tear it off, or do you have like
We can clip it off. Here's a razor blade, if you want.
yeah?
There you go.
Okay.
So this is a pretty simple mold. The more
Yeah.
advanced molds have auto gate braking
Oh, okay.
features, but we don't need to get into that today.
I do see a line here.
Yeah, yeah.
Is that something that let's make sure the camera sees it as well? Do you see a line there?
Yeah. I
And
wonder if that's a fracture.
that's a fracture. Okay.
Does it look like a fracture?
No.
Yeah, I think this is remnant of the last plastic.
Oh, okay, okay.
So,
We'll check if the AI can figure that out.
yeah, I think this is a streak of the nylon,
Okay.
because we didn't purge this machine heavily,
Yeah.
so that's probably nylon streak,
Nice. It's a streak defect.
I think.
Okay.
But yeah, there you go.
Perfect. So yeah.
You see how this is flashing, so it's saying as soon as you hit that cycle start button again,
Yeah.
it's happy. Another thing to consider is the molding machine is telling you that a startup cycle is active,
Okay.
and that's its way of telling you that your first 10 parts are usually not production parts
Oh, it's a startup. startup
because
part,
you're
so
not
yeah.
in a repeatable
Steady state.
steady state zone.
Okay.
So it actually warns you startup cycle active,
Yeah. Yeah.
and usually people throw away the first.
For the first few parts.
Yeah.
Okay. Okay. Is it still hot right now in there? Is it maintaining a temperature?
Yes.
Okay, I see
So
the temperature.
these are the heater bands on the injection unit,
Yeah.
and you can see this little green line.
Yes.
That's telling us that we're in our tolerance spec,
Okay.
and if these green lines start to get bigger
Yeah.
or start turning blue,
Okay.
that means you're out of your approach. You're deviating from your temperature tolerance spec.
Okay. Okay.
We
Okay.
can go to the temperature page,
Yeah.
and it basically zooms in on that. So that tells you here's your temperatures.
Mm-hmm.
The yellow, I think, is the set temperature.
Mm-hmm.
The green is the actual temperature.
Mm-hmm.
And this green bar is your acceptable range, which for us
Ah.
is plus or minus 10 degrees Fahrenheit.
That's the limits. That's the process limits, basically.
Yes.
Okay.
So if we deviate out of that range, then the
Yeah.
molding machine will stop,
Oh, nice.
and it will tell you you're out of range.
Perfect.
This is a nozzle cooling jacket, so
Yeah.
there's water flowing,
Okay.
so that we don't get the hopper too hot, because you can get
That makes it hot.
blockages.
Yeah.
If the hopper, the bottom of the hopper can get so hot that the plastic starts to clump in there,
I see.
and it won't flow into the actual injection unit.
Injection molding. Yeah.
It's
yeah,
called
okay.
bridging. Yeah.
Oh, okay.
So a lot of molding machines now have a cooling jacket, so that the pellets can keep flowing. It doesn't happen immediately,
Yeah.
but if this machine runs for 10 hours,
Yeah. Yeah.
then it heat soaks, and it'll start actually having problems with the pellets prematurely melting.
Okay. and the cooling is happening at 194 Fahrenheit.
Yes.
And the actual injection molding, the melting is happening at 430 to 450 Fahrenheit.
Correct.
Okay.
Yeah.
So yeah, it's still hotter than normal, but it's still cooling it.
Correct. Yeah. Yeah.
Perfect. Okay.
Yeah. As the bottom of the hopper starts to get to 350 degrees,
Yeah.
those plastic pellets
Yeah.
will start to get sticky, and then they'll just clump,
Yeah.
and then you're done because
Okay.
you've run out of plastic in your actual injection unit at that point. And it happens, 10 hours later after you've gone home or whatever.
So like a lot of, you come back and like a lot of your
No,
material
you just see a flashing red light
I see.
because they can't fill the next shot. So
Okay.
it just says, I can't fill my shot, I'm stopping now.
Saves it.
Yeah.
What's our next step?
Okay, well, it just told us that our cycle time exceeded because we were talking too long.
Yes.
So see how it kicked us out of semi-automatic mode and it put it back to caution mode. It
Yes.
says, something's not right.
Yeah.
I'm getting out. So then we can hit semi-automatic again.
Okay.
Oh, I think we have to acknowledge the error. And since we got out of our production cycle,
Yeah.
it said, oh, you're back in startup cycle again.
Okay.
Because you deviated
Too much.
from the standard cycle.
Okay.
And just sitting from one shot to the next and
Yeah.
talking, shooting the breeze with someone,
Yes.
this machine's saying, oh, you deviated. So
yeah. You need to focus on
nothing's
this.
right now.
Make sure you're working on it.
Yeah. So we're talking again. So why don't you hit the button?
Yes.
We're still in semi-automatic mode, so we'll do one more cycle.
Okay. And we do 10 such cycles before we actually produce.
No, we can go to fully automatic mode, but the machine is just warning you that traditionally you're in startup, so you probably shouldn't sell these parts to customers. Did it? Uh-oh. We got a part on the wrong side.
Oh, that's a defect we just discussed.
Yeah. Oh, wait, who designed this mold? Okay, so what we need to do now is go into caution mode.
Yes.
Or if we're in semi-automatic mode and we open this door, then the machine will lock us out. Actually, it stayed in semi-automatic mode, but there's safety interlocks on this machine. And when this door is open,
Yeah. So
it's
that's it.
impossible for this mold to close.
Okay.
Except you should never assume that it's impossible.
And it is very hot, right?
No, this mold is at room temperature.
Okay, only the liquid inside is hot.
Yeah, but if I wanted to tell it to mold right now, it's saying no, close the safety door.
Okay.
So and there's 3 interlocks.
Yeah.
There's a mechanical lock, an electrical lock, and a hydraulic lock. All to keep you from getting your hand smashed in this mold. So it's very important. But never assume
Yeah.
that the safety interlocks are going to save you. So it's best not to dwindle
Yeah.
in there. I need to get a tool to pull this part out. So I'll be right back.
Okay.